Good afternoon, everyone. I request everyone to please mute. Good afternoon, everyone, and wishing all a very happy new year. And we are starting this year with a very good note, and we are starting with our Water Tech Talk. And I'm Anupma, the director and editor of Water Digest. I welcome all of you in today's program, the Water Tech Talk, being organized by National Water Mission and is supported by Water Digest. We have our wonderful speaker today, and to reveal further, I would like to invite Honorable Shri G. Ashok Kumar, Additional Secretary and Mission Director, National Water Mission, to kindly propose the welcome address and also tell us more about today's Tech Talk and the speaker we have. Over to you, sir.
Good afternoon, everybody. Good morning for the people who are joined from Sweden, Austin and Rupali, our friends in Sweden. And with the digital platform, we don't know from where people are coming in. We had people participating from Australia last time, from Nigeria last time, somebody from Dubai was there. So it's a good timeless integration, seamless integration which we have thanks to the digital platform provided by Anupama ji and the team. Welcome to the fourth edition of the Water Tech Talk, because we feel that technology matters, the pun intended, the technology matters for real engineers. So this program we started about four months back to make the engineers and the water scientists in India aware of the cutting edge technologies in water. In National Water Mission, which was formed as part of the National Action Plans Against Climate Change, formed in 2011 and picked up activities in the last couple of years. We had been addressing various issues related to water, whether it is increasing the water use efficiency, which is a very low in India, about 30-35%. We are also addressing the various demand side management by trying to talk to the farmers and agriculturists who seem to consume a lot of water, which can be really reduced if proper technology is given to them and proper crop selection is given to them. We had a campaign called Sahi Fasal with the farmers to actually from water-intensive crops to reduce the water unnecessary water usage in the country and to improve the water use efficiency. We also have conducted are conducting lot of water audits in the industrial sector and also trying to work with various institutions to improve the water efficiency in the industrial sector by introducing new technologies and also to facilitate them with technology re-engineering so that the process re-engineering so that the water can be saved. We also try to push them with the concept of reduce water, reuse water, and recycle water, 3 Rs. And we also, from our side, added 2 more Rs, the recover and regenerate rivers and respect for water. We feel that the first and foremost thing which we do is to increase the respect of water. So we have started many campaigns on that. One of the big campaigns which we have started and is going on is called the Catch the Rain, with the tagline, catch the rain where it falls, when it falls. Basically, it is a decentralized sort of water collection, because we had in the past built many dams, large water was to be taken on some big storage areas, big, over 5,000 tanks have been constructed. And we are now doing the study on the efficiency of the water in the sector. That's really not very up to the mark. So we are looking at a decentralized solution by requesting everybody to catch the rain and store it. It is like the opposite of crowdsourcing, where it's like crowd saving, the opposite of crowdsourcing, where everybody stores the water and everybody stores small amount of water, which can really be good. So Rupali may understand when I say this. We are aiming for a tanker Mukt Bharat. See, normally what happens, we have a lot of problems during winter, rainy season when rains fall and creates a lot of havoc because of the torrential rainfall and the water runoff from the cities and towns. It goes down the rivers in such a force. It carries away a lot of houses, people's properties, mobile properties like even cattle. Everybody gets some of them get killed in this floods. And after some 2 months, when the flood is over, after 3-4 months, we find suddenly there's a shortage of water and tanker is service to provide drinking water. What we are trying to do is to connect these two by making the water, rainwater stored, so that we can use this water for summers for drinking water, and can eliminate the big set of people called water tanker suppliers, who actually supply this water and creates a lot of problems in summer times because of their overcharging and all these things associated with that. So that's what we came by Tanker Mukt Bharat. And the last one is that we also felt that if you store this water at the households and small locations, we can find an answer to the urban flooding issues. Urban flooding is another issue which had been ravaging the country in the last couple of years because of the encroachment of the water storage areas, because of the increased urbanization and low permeability in urban areas, and the rapid urbanization which is happening in India. There's a lot of water which flows into the low-lying areas of the city and creates water logging. These are a couple of the issues which we are addressing. And we have been doing talks, water talk, every third Friday. And we also had discussions with the collectors in the district heads every week, every Saturday, on what they are doing for the conservation of water. And now we have this water tech talk, where we ask the experts, the luminaries in the field of water, to come and talk about the cutting edge of water technology. So it's another 1 more minute for my talking, and then we go to the movie. So we will, with your permission, Eston, we will be going for a 7 or 5-6 minute video on the National Water Mission's activities, and then I will introduce our keynote speaker today, Eston Kim Gren, who has distinguished career in water, and we had the opportunity to visit him. We went for the Stockholm Water Summit. So before I invite this honored speaker, I will show a video on the National Water Mission, which will be of use to all of you. It is in Hindi, but I hope the visuals will be able to make you understand what we are doing.
गंगे च यमुने चैव गोदावरी सरस्वती कावेरी नर्मदे सिंधु जलस्मिन् सन्निधिं कुरु। जल ईश्वर स्वरूप है, सौम्य, शालीन, जीवनदायक। प्रकृति का दिया ये जल रूपी वरदान पृथ्वीवासियों के लिए सिर्फ एक विरासत नहीं, बल्कि एक जिम्मेदारी है, जिसे आने वाली पीढ़ी के लिए संभालना आवश्यक है। और इस उद्देश्य की ओर पूरी निष्ठा से कार्य कर रहा है राष्ट्रीय जल मिशन, जल शक्ति मंत्रालय, भारत सरकार।
खेती के उपयोग में आने वाले पानी का अधिकतम उपयोग हो, इस दृष्टिकोण से मंत्रालय माननीय प्रधानमंत्री जी के मार्गदर्शन में काम कर रहा है। और हमने नेशनल वाटर मिशन में 20% तक पानी के उपयोग में कमी लाने का लक्ष्य रखा है। सतह पर जो जल उपलब्ध है उसका उचित प्रबंधन, भूगर्भ के जो हमारे स्रोत हैं उनका ठीक से उपभोग हो, जो पानी हम अलग अलग क्षेत्र में उपयोग में लेते हैं उसका विवेकपूर्ण उपयोग हो, और उसके साथ साथ में जो पानी उपयोग के बाद में निकलता है उसका ठीक से ट्रीटमेंट हो, तो हम जल सुरक्षित देश को बना सकते हैं।
जलवायु परिवर्तन का विशेष ध्यान रखते हुए नेशनल एक्शन प्लान ऑन क्लाइमेट चेंज के तहत नेशनल वाटर मिशन की स्थापना की गई ताकि जल संरक्षण को बढ़ावा मिले, जल की बर्बादी को कम किया जा सके और राज्यों के भीतर एवं राज्यों के बीच जल का अधिक समान रूप से वितरण सुनिश्चित किया जा सके। राष्ट्रीय जल मिशन के प्रमुख उद्देश्य हैं जल का डेटाबेस सार्वजनिक रूप से प्रस्तुत रखना और जल संसाधनों पर जलवायु परिवर्तन के प्रभाव का आकलन करना, जल संरक्षण वृद्धि और संरक्षण के लिए नागरिक और राज्य कार्रवाई को बढ़ावा देना, शोषित क्षेत्रों सहित संवेदनशील क्षेत्रों पर ध्यान देना, 20% तक जल उपयोग कुशलता में वृद्धि करना और बेसिन स्तर के एकीकृत जल संसाधन प्रबंधन को बढ़ावा देना।
देश के अंदर जितनी भी वर्षा होती है एक वर्ष के अंदर, हम उसका केवल 8% ही बचा पा रहे हैं। तो ऐसी दृष्टि को मद्देनजर रखते हुए हमें युद्ध स्तर के ऊपर जो है अपने जल प्रबंधन के कार्य को आगे बढ़ाने की आवश्यकता है और हमारा मंत्रालय जो है उस दिशा के अंदर सतत प्रयास कर रहा है।
अपने लक्ष्य की ओर बढ़ते हुए राष्ट्रीय जल मिशन ने अनेकों कदम उठाए हैं, जिसके तहत कैच द रेन नामक एक खास कैंपेन शुरू किया गया है, जिसकी टैगलाइन है कैच द रेन वेयर इट फॉल्स व्हेन इट फॉल्स। इसमें राज्य सरकारों, सामाजिक संस्थानों, सरकारी और गैर सरकारी संस्थानों से एप्रोप्रिएट रेन वाटर हार्वेस्टिंग स्ट्रक्चर्स का निर्माण और उसके उपयोग का अनुरोध किया है, जो कि वहां की सॉइल और क्लाइमेटिक कंडीशंस के अनुरूप हो और वर्षा के पानी को बचाने और कुशलता से उपयोग करने की इस मुहिम में अधिकाधिक लोगों को साथ जोड़ने की पहल की गई है। साथ ही विभिन्न कलेक्टर्स को जिला स्तर पर रेन सेंटर्स की शुरुआत करने का अनुरोध भी किया गया है, जिसके माध्यम से आम लोगों को वर्षा जल संचय से जुड़ी तकनीक की जानकारी दी जा सके। कुछ प्रमुख संस्थानों और मंत्रालयों ने वर्षा जल को संरक्षित करने के लिए कदम भी उठाए हैं। जल संरक्षण में समाज की भागीदारी को बढ़ावा देने के लिए कई संस्थाओं को भी साथ जोड़ने की पहल की गई है।
Both in urban areas and rural areas, rainwater harvesting system must be made mandatory when sanctioning plans. We must ensure that water is not wasted and the groundwater reserves are recharged when the rain falls on the ground. We must catch the rain and store it. I'm happy that the National Water Mission's campaign is taking up a timely initiative called Catch the Rain When It Falls.
वर्षा जल संचय की महत्ता को ध्यान में रखते हुए समाज की जानी मानी हस्तियों ने भी इस कैच द रेन कैंपेन को बढ़ावा और सहयोग दिया। राष्ट्रीय जल मिशन लगातार जल संरक्षण हेतु ट्रेडिशनल वाटर सिस्टम के रिवाइवल के लिए कार्य कर रहा है। इस दिशा में भारत के स्टेप वेल्स की धरोहर को संजोते हुए राष्ट्रीय जल मिशन द्वारा स्टेप वेल्स ऑफ इंडिया नामक एक किताब लोकार्पित की गई, जिसमें 100 यूनिक और इंटरेस्टिंग स्टेप वेल्स की जानकारी मौजूद है।
ग्राउंड वाटर जिसको हम भूजल कहते हैं, उसका दोहन इतना ज्यादा हो गया है कि आने वाले दिनों में वहाँ पानी बिल्कुल ही उपलब्ध नहीं होगा। तो इसलिए जो ऐसे इलाके हैं, खासकर वल्नरेबल एरिया जिसको हम बोलते हैं, उन क्षेत्रों के लिए भी काम नेशनल वाटर मिशन कर रहा है। पानी का प्रबंधन केवल केंद्र सरकार या राज्य सरकार के प्रयासों से नहीं हो पाएगा। जिसको हम कहते हैं पार्टिसिपेटरी इरिगेशन मैनेजमेंट, वो बहुत जरूरी है। जैसे अब एक वाटर टॉक की सीरीज शुरू की गई है, जिसमें जल संगोष्ठी का आयोजन करके लोगों को जागरूक करना, कैसे लोग पानी को बचाएं, कैसे पानी का सही उपयोग करें, इस दिशा में भी नेशनल वाटर मिशन काम कर रहा है।
जल संरक्षण की अधिकाधिक जागरूकता और प्रशिक्षण का फैलाव भी किया जा रहा है, जिसके तहत वाटर टॉक नामक लेक्चर सीरीज चलाई जा रही है। इस पहल को ज्यादा से ज्यादा लोगों तक पहुंचाने के लिए इस वाटर टॉक सीरीज को डिजिटल प्लेटफॉर्म के माध्यम से आगे पहुंचाया गया और जिसके कारण न केवल प्रतिभागियों की संख्या बढ़ी, बल्कि देश विदेश से भी लोग इसमें शामिल हो रहे हैं। साथ ही इन वाटर टॉक्स का सार एक बुक में भी कंपाइल किया गया है। इसके अलावा नेशनल वाटर मिशन की तरफ से वाटर कंजर्वेशन के अलग अलग टॉपिक्स पर टेक्निकल सेमिनार्स और वेबिनार्स भी किए जाते रहे हैं। साथ ही जिला अधिकारियों और म्युनिसिपल कमिश्नर्स के साथ वीकली वेबिनार्स भी किए जाते हैं, जिसमें उनके द्वारा उनके क्षेत्र में की जा रही बेस्ट प्रैक्टिसेस की चर्चा की जाती है।
एवरी डीएम्स को रिक्वेस्ट किया कि हर जिले में एक रेन सेंटर नहीं तो एक जल शक्ति केंद्र खोलने के लिए। जल शक्ति केंद्र में जल के बारे में जितने भी जानकारी लोगों को मिलना चाहिए उसी के बारे में जानकारी मिलते हैं। बट वी हैव टू मेक पीपल अंडरस्टैंड द वैल्यू ऑफ वाटर and engage them in discussions, engage them in the thinking about the value of water, so that they leave behind a very good legacy for their next generation.
सिंचाई क्षेत्र में सुधार के लिए 26 बेसलाइन स्टडीज भी की गईं और साथ ही मांग प्रबंधन यानी डिमांड साइड मैनेजमेंट के लिए सही फसल नामक कैंपेन चलाया जा रहा है, ताकि किसानों को उनके क्षेत्र के अनुसार कम पानी की खपत वाली फसल की बुआई के लिए शिक्षित और प्रोत्साहित किया जा सके। और इसके लिए किसानों को वर्कशॉप्स भी दी जा रही हैं। राष्ट्रीय जल मिशन के इस कैंपेन के चलते कुछ राज्यों ने क्रॉप डाइवर्सिफिकेशन को प्रोत्साहित करने के लिए अपनी पॉलिसी में बदलाव भी किए। औद्योगिक क्षेत्र में भी जल के कुशल उपयोग के लिए नेशनल वाटर मिशन लगातार निगरानी बनाए हुए है, जिसके तहत कई विभिन्न उद्योगों में वाटर ऑडिट्स भी किए जा रहे हैं। BIS की पार्टनरशिप के तहत वाटर अप्लायंसेस के स्टार रेटिंग का काम भी हो रहा है। जल क्षेत्र में स्टेट स्पेसिफिक एक्शन प्लान की संरचना के लिए राष्ट्रीय जल मिशन द्वारा राज्यों को वित्तीय सहायता भी दी जाती है। इतना ही नहीं, विभिन्न रूप से जल संरक्षण को व्यवहार में लाने वाले संस्थानों को प्रोत्साहित करने के लिए नेशनल वाटर मिशन अवार्ड्स के जरिए 45 लाख रुपए तक के कैश प्राइजेस भी वितरित किए गए। साफ पानी और स्वच्छता मानव जीवन को पूर्ण रूप देते हैं। ये सच है, जल जीवन है, जल ही शक्ति है।
That was a video on the National Water Mission. So, in continuation with the previous the series started by Neil Pintov of the Israel National Water Company, then we had Mr. Dr. Rajiv Sinha of IIT Kanpur and Dr. T. Pradeep from the Department of Chemistry, IIT Madras, who talked about harvesting humidity for clean water. Today, we have Mr. Esten Ekergren of the IVL Swedish Environmental Institute. He is also the Vice President of the IVL Swedish Environmental Research Institute, Executive Vice President, to talk about the reuse and recycle of the wastewater. We had the opportunity, the Minister, Gajendra Singh Shekhawat ji, and myself and his team of officials also had the opportunity to visit some of the facilities of the IVL in Sweden when we went to attend the World Water Summit in 2019. We went to Hamar Hugers Kostervekt, I don't know how to pronounce it. It's a Swedish name. Where there is a membrane bioreactor technology. They have constructed a wonderful water treatment facility with very little footprint for taking the cleaning the sewage water. So these are the new technologies which the Sweden and the IVL has been doing it. So he has been responsible for building up environment technology department in IVL, and also works closely with the Swedish government for exporting the wonderful technologies developed in Sweden. Mr. Ekegren is also a member of the Euro Environment Umbrella, EURECA, and where he promotes the various new technologies developed and shares various technologies shared by the various members. So without taking much time, I request Mr. Austin to deliver his talk. And at this time, I also remember and thank Rupali Deshmukh, who is instrumental in getting us to him. Thank you. Over to Mr. Austin.
I'd like to share my slides. Okay. Good afternoon, everybody. I will first just briefly introduce my institute. From the beginning, I'm a chemist myself. I studied at the Royal Technical Institute in Stockholm. And after that, I've been working with IVL since 1978. So it's a long time. And Rupali joined our institute a couple of years ago, and she is now responsible for our India business, but also working a lot in the field of water treatment. IVL is quite unique construction. It is mainly owned by both government and industry 50-50 through a foundation. And we are in that way independent. So we have the representative in the board comes from the industry half and from government the other half. And we have very good turnover, but all the money goes back to research. So we are a non-profit. And we have been running since 1966. Turnover roughly last year was about $40 million US. We are 350 people. We have different backgrounds, engineers, biologists, geologists, and more economic skilled people. Our idea is to be the bridge between university and the industry need and society need. And we should do applied research, but also basic research. We have offices all over Sweden, and we were established in China in the beginning of the 90s. And now we are happy that last year we established our first office in India, in Mumbai, where we are working with MCGM to follow the establishment of the wastewater treatment plant in Mumbai. We are also doing a lot of our funding comes a bit from the government, 1/3, but we don't have any money from government if industry doesn't pay the same amount. And this has been a very good way of doing research, because if industry find an interest and pay, government know it's a good problem to solve. So that has been quite successful, I will say, the way we are handling this. And most of the money comes from European Union. We are running more than 30 European funded projects for the moment. Areas, we started with air. Air is fundamental for everyone. And we are struggling with bad air quality, especially in cities all over the world. I found in Delhi last time I was there a really bad air quality condition. We have similar in Sweden when I grew up like 40, 50 years ago, when we have more industries. Still, even in Stockholm, we are below all the limits, but still we calculate that several thousands of Swedes dies earlier because of bad air quality. So this is extremely tough issue with air quality, which we have to struggle with, I would say, all over the world. I have not found any city in the world that has an air quality that is good enough. We are working a lot with chemicals to avoid using problematic chemicals, and on the other hand, using chemicals where they do a very nice work. Climate and energy is more on top of the agenda, and we are focusing in a lot on this. We have collected data since the beginning, so we have an open source. So we have air quality data and water data since the 60s, which will be open to researchers all over the world. And this is a very important issue because many of the data is normally hidden and problematic to get. We develop technologies, I will come back to that later. Sweden is covered by forest 70%. So we must be careful how we are using the forest. And we are producing a pulp and paper, but also more and more energy and fuels from that. We are working with the product, resource efficient product, because the use of the car, of the refrigerator, is more problematic from an environmental point than just the production. We focus a lot on transport. In Sweden, the emission of carbon dioxide, 1/3 comes from the transport, 1/3 from industry, 13% from farmer. Waste has been in focus a long time. We want to develop a more circular society for waste. Give you a few examples, even if it's not on the agenda today. And water has been the base for our work since the beginning. Today we will focus on water treatment, but we are also covering other aspects of the water in our research. Some of our project, Hammarby Sjöstadsverk, I will come back to that. I'm happy that Chairman remembered the visit to this pilot plant, and we have some ideas how we can start to cooperate with India in this field. For waste, could be of interest for you as producing a lot of textile. In Sweden now we develop a sorting machine, so the different clothes, every Swede buys 14 kilo clothes a year and 7 kilo goes as waste. And this is the main problem, that we are buying too much. But we must take care of that waste, so we have developed a machine to sort out the clothes with the best fibers. And then they will go to a factory when you dissolve it in acids, and the textile fiber can be recycled and start to produce new clothes. We do similar for the cars, where you don't have recycling technology for all of the pieces, especially the batteries. For climate and energy, we have been asked to find out how Sweden can be fossil-free the year 2045. So we focus a lot on that. And we are also working a lot how to combine the industry, different industries with each other, so that energy can be shared between the industries, but also with the society. So, for example, we have now one city in Sweden where 2/3 of the energy of the heating up and cooling in the city comes from the outlet of the industry. And we call that industrial symbiosis. And this is more and more important in the society, to link different actors to each other. We are also engaged by the Swedish government to help them to present what Sweden can come up with. We have only 10 million inhabitants, but we have a lot of visitors, and IVL is asked to collect all the good references to present when visitor comes, as Mr. Kumar mentioned, at the World Water Week. So we have like 180 delegation in 1 year coming in to learn about different aspects, but also to discuss and find a way forward. And we organized this and we collected with 1,500 clean tech companies. And this is open for you to find out. You just visit our homepage, www.smartcitysweden.com. And we have many delegations coming in from India at different purpose, waste, water, but also greening of the city and transportation. The storytelling is connected with the 17 Sustainable Development Goals. And I think every city, every country is struggling with this, how to reach the goals. And when OECD did an evaluation, Sweden was ranked number 2. And you can be proud of that, but you can never be satisfied. We are far away to reach some of the goals until 2030. But we think there are 4 components that is very important. First is innovation. Sweden spent 3.3% of GDP for research and development, and 2/3 of those money comes from industry. So you must always try to be better and develop new solutions. And for that, you need funding. You need that the researchers can do a good work. But you also need to involve the citizen. We learn from history that we have not listened so carefully to the citizen when we develop the cities. If it should be more sustainable, they must be involved so we know that they are able to pay for what we build up, but also that we give them the transport solution that is needed, that the energy consumption in the houses is good, and so on. And we think that the way forward is more system solutions, because we need to be more holistic in the way we are thinking and acting. And we call it eco-governance. And eco-governance meaning is that we learned in the 90s when we developed new part of the city that the city were organized in silos. So the responsible for water and sewage never met people being responsible for energy or for traffic or for waste. And this must be changed. The responsibilities should be there, but you should have set up a common goal for the city so that the actors come together and see how they can develop solutions together. So I will then focus on how water, in this case, can be connected with waste to energy, to the transport, to the air quality, to the bioeconomy, circular economy. And we are not 100% good in that, far away, I will say. But we understand more and more, and especially from the research point of view, that this is needed if you want to find smarter and sustainable solutions. So if we look at water, historically, we started 100 years ago. We got the same idea in Sweden as elsewhere. We just let out the water into the sea because the sea was so large, so nothing could happen. But it happened. So in the 1930s, we introduced the first step, mechanical treatment, to take away organic. But this was not enough. So in the 60s, we had to add biological treatment to take away more of the organic and also a bit of the phosphor. But we found out that it was not enough. So we had to add chemical treatment to lower the phosphor concentration in the outlet water. And this is a typical solution where we have all over the country. But we also have to take care of the nitrogen. So in the 90s, the government gives subsidy to introduce treatment of nitrogen. As you see, it's not 100%, it's like 70 to 80% that will be taken away. So what is happening now, where IVL is deeply involved, is that in Stockholm, this Henriksdal is the largest wastewater treatment plant. It will be for 1.6 million people, where we have now introduced the membrane bioreactor, and they do it stepwise. We have been evaluating 2 different membranes for 5 years, and we do it in such a scale so it can be upscaled. By doing this, we take away the secondary clarification and introduce the membrane. And by doing that, we can take away more of the nitrogen and also of the phosphor. But it also very good because you don't need so large space. And that is the main driver. We don't have the space in the city to enlarge the capacity. Now, this plant will be doubled in capacity with the same area. So what we have done, and I come back to that later, is that we have optimized the membrane before it is introduced in full scale, so that all mistakes can be taken in a small scale, and then when you go to full scale, you know how to use the membrane in the smartest way. But as you know, we also have learned more and more that we have pharmaceutical residues in the water. So we have focused on that for 5 to 10 years now, how to deal with that. We have phthalate esters, we have flame retardants, we have phenolic substances, and we have PFAS, which we have studied very much during the last years. It came from a fire-resistant chemical. It has been used with the fires, but also of the military. We found it now in groundwater, which is very problematic. It is quite stable, so we need to get rid of it. We have also studied microplastic, only to minimize the amount of microplastic coming to the treatment plant, but also to treat it carefully. And antibiotic-resistant bacteria is something that is coming up as also a large problem. And on top of that, we have POPs. So this means that we need to treat a bit more. But on top of this, we have this treatment plant, and we also have still problem with the sludge. What to do with the sludge? The better you treat, the more sludge will be produced. And how to recycle the nutrients that comes into the plant. And especially also that wastewater treatment plant consumes large amount of energy, which give greenhouse gases out. So in a way, we have not solved totally the problem by having a treatment facility. We have the environment with a much better water going out, but it's not good enough. And on top of that, the main problem for water is the global water stress. Here, this is from 2013. And you see India here is called high stress, meaning that 40 to 80% of the available water will be used. This is dramatic, I will say. I was in China a year ago when you could not establish a factory in one city because they don't have water. I've been to Chile in Antofagasta, where we start a project now to recycle the gray water because they don't have any water at all. They must produce from the sea. California, similar, South Africa, North Africa, South Europe, Middle East, Australia, and they are also connected with the fires you could see on TV. And this will be worse. So now also outside Sweden, we have problem with water shortage, which we could not foresee 10 years ago. But on the other hand, as was introduced in the film, in some areas you will have much more rain than you really want. So how to collect it and how to use it. And the problem is that also that demand worldwide is growing because we are more people, we need more food, we need more production, and we need more water for the residents. But the amount is not growing, it is going away. Most of it, the fresh water, is in the snow and ice, in Himalaya or in the Alps or in all mountain and the North and South Pole. And it is melting away. A small amount is in the lake and river, and we have polluted that very much. So everyone cannot be used. And the groundwater is also a lot, but we are also contaminating our groundwater in a quick way. So it is problematic to look at the future with the solutions that we have been coming up with. So we think that we need to rethink and start to build up a treatment plant. We want to see wastewater as a resource, and we should treat it so that the water can be reused to the farmland, to the industry, or even to the groundwater. And we should do that by producing energy and nutrients that can be recovered. And by doing that, we can also tackle the problem with the pharmaceutical residues, POPs, COVID-19, for example, that is coming up as a problem now. By doing this, we will have a more circular economy and circular way of the water. We have studied pharmaceutical residues for many years and found out that we can take away more than 95% of the pharmaceutical residues with ozone or activated carbon. Both are working quite well. So based on our research last year in May, this plant in Sweden with, it's not a very large city, you see it's 270 cubic meter per hour that will be treated. But we treat it first with a disc filter to take away the particles, and then we use ozone to degrade the pharmaceutical residues as well as other POPs. And because ozone might not degrade all of them, we have a polishing step with activated carbon to take away what is left. We have now analyzed this outgoing water for a long time. We have very good result. You take away the pharmaceutical residues to more than 95%. Why I'm saying more than 95 is that it's such a low concentration, so sometimes it cannot be measured. And we found out that if we treat that water with UV, this can be recycled to the groundwater. And in the area, they have water shortage. So this is a very good alternative for them. But when you want to recycle water, people are anxious, especially if you want to go back to the groundwater. You should not disturb the groundwater quality. And if you go back to agriculture, it should not contaminate the land, or to industry, it should not disturb the production. And how can you convince that this is a good way forward? We did this. We took the wastewater from Stockholm City that was treated in the ordinary way with activated sludge. And then we use an ultrafiltration, reverse osmosis, activated carbon, and UV light. And that water was extremely good quality. And we took that water and used to produce a beer, Purest. we produced more than 6,000 liters. It has been sold all over Sweden, and it is, I would say, quite good. It depends on your own taste, but I like it. We will not continue with this even if they have asked us, but it was for us to show that you can reach a very good quality. We have analyzed more than 150 substances, so we are pretty sure that the quality is good. It was too good, so we had to add salt. Otherwise, it should not have been as good as it is. The price to buy a bottle of beer in the shop is $2 per bottle. To treat the water is less than 1% of that. So it tells you that it's extremely efficient way to go some more steps longer when you start treating. When you are treating, as I said before, you come up with more and more sludge. And we did that as well in Sweden. So what to do? First idea is always to build up a landfill, and then you have the problem there. So we started to introduce digestion so that we have half the amount after doing the digestion. And that was good enough. But then we also realized that we produce biogas. So we started to see that the biogas can be used to produce energy. So now all over Sweden, we have an every wastewater treatment plant that is relatively large. You have anaerobic digester, and we produce roughly 2 terawatt-hour biogas now in Sweden. It will increase to 10 terawatt-hour in the near future because we want to introduce also the organic household waste. The biogas can also be produced with waste from a kitchen in the home, schools, hospital, restaurant. And now the government in Sweden has decided that at least 40% of the organic waste from the household must be used to produce biogas. So we build up a collection system. But it's also a lot of waste from food industry and from farmland that can be used. In Sweden, it's roughly half of the amount comes from the sewage sludge. And then we have from landfill, and then we have from the organic from household. And this is growing quickly. What we are doing is that when you run an anaerobic digester, you reach like 65 to 70% methane concentration. When you upgrade this to 98, you can use it as a fuel. It's similar to natural gas. So it has been used in Stockholm since 1989. And it gives less fossil carbon dioxide emission. So it's a good alternative to introduce when you are switching to electric buses. So as you see, Sweden is the leading country in European Union to use alternative fuel. Not only biogas, but more and more biodiesel and also bioethanol. So we reach already the year 2012, 10% alternative fuel. And we are doing this as a strategy because we think it's too expensive. It takes longer time to switch everything to electricity. But we introduce, of course, more and more electricity-driven cars, buses, and now even lorries. So this is a combination which we think is quite good. And we think this is a good suggestion also for India, because if you look at the biogas production worldwide, you see it's Europe like half the amount. And so you see also that Asia can really grow. So we are now working with such projects in China, but now also luckily in India. So we think this is a good opportunity when you build out a wastewater treatment plant. So if you sum it up there, that the production of biogas, it can come from both the wastewater and from other sources. The reuse of treated wastewater from a sewage treatment plant is needed more and more. And if you look at the problem that 2 billion people is lacking fresh water, if this water should be produced from seawater with reverse osmosis and electricity comes from coal power plant, if you compare that solution with the one that we have here in Sweden, when we add ozone treatment and activated carbon and UV, you will have emission of more than 200 million tons of carbon dioxide more from the solution when you take it from the sea. So this means that the smarter the circularity will be, it is also good for environment. But we have now been talking about the water use in the households and how to treat that. But it's also an increasing demand for water, especially for farmland. I come back to that, but also for industry. In Sweden, 70% of the fresh water will be used by the industry. So this differs between countries. But as you see, also in India, it is a growing demand for more use of water in the industry. And this water is normally more problematic because it contains substances that can be dangerous when it comes out. So you start normally with chemical precipitation to minimize the amount going out. And this is the first good step. But then the question comes up, what to do with the sludge and how can this come into a circular way of thinking? So therefore, the idea in Sweden and I think many countries is to go inside the factory and start to minimize the use of water in the process. So we introduced a counterflow rinsing for many years ago, and it has been quite successful to lower the amount of water needed. And then we have been thinking of the industry as with our own bodies. You know, we have a kidney that is working nearly all our lifetime without being repaired in many cases. So we should have similar way of thinking for the process path. So it has been introduced different kidneys, and the kidney can then be an ultra filter, or it can be an evaporator or some other technology where you can recycle the chemicals, take away the impurities, and then run it with much better efficiency. An example is a car production. This is from the Volvo production line, where you have the pre-treatment before the painting. And then you have a degreasing and rinsing step, you have a phosphating step, and then you have the painting. So what has been introduced based on our research in full scale, this is in Belgium, where you treat the rinse water with reverse osmosis and with evaporation. We don't need to go into detail, but with this solution, you minimize the water consumption and you recycle more of the chemicals. Recently, we did this with another Volvo company. Then we were using evaporator, and then the concentrate will be recycled in another factory. So this is a solution that comes more and more. But on top of that, you are using multivariate data analysis. So you can calculate the quality based on the information you have from the process path. Normally, you have to wait for months for the corrosion test. But with this new way, you can see in real time what will be the quality of the painting. And this is a very important step forward, because quality is the competing edge. So it must follow that you're resource efficient, but you also find good quality. This is another example from a brewery where we took the rinse water from to clean up the bottles. We invested in a reverse osmosis unit, recycled the water, and here the driver was the cost for the water. So the payoff in this case was 2.7 years. So this was installed because it was lower than 3 years. And this has now been introduced in many breweries all over the world. I said that we have also a lot of the pulp and paper industry. Here you see that they have lowered the amount of water per ton pulp produced by introducing different alternative steps. So I just show it as an example, another example where you can lower the use of water by changing the process and the way water is used. We'll skip this. As introduced by the chairman, it's a lot of rain coming. This is a part of an island outside Sweden, Gotland, where you see that the rainfall is 20 million cubic meter, but the need is just 0.2. And what's happening is that the water runs out in the sea quite quickly. So we have a project now for all this area. This is 20 multiplied with 10 kilometer. So what we do is the first step is to measure the groundwater online. And then we have automatic control of the floodgates in the ditches. So we can really stop and collect water when it's needed and let out when it's needed. And thirdly, we are building up groundwater pond below, because if you have it on the surface, evaporation is, even in Sweden, quite quick. So it disappears. So we try to build it up in the ground, and we are using new technology. We also produce some fresh water by using solar cell for desalination. But we're also treating the wastewater from the plant in this region. And we are recycling the rainwater, and we are using more simple technology to treat it so we can take it back to the groundwater. And this is quite interesting because those ideas Rupali brought in from India. So this is an area where we also have learned from you how we can tackle this. Coming back to this Hammarby Sjöstadsverk, which is our pilot plant, we call it Swedish Water Innovation Center. We have been running this for 13 years. It's a unique R&D facility. We have access to wastewater from Stockholm, but also from wastewater from Hammarby, which is a green area. We have 5 different treatment lines with 4 cubic meter each per hour. It's a relevant scale to go upscaling. We have a testing of new technologies. We include sludge handling, biogas production, system integration. We cooperate with 5 universities and 2 research institutes. We have all the time 3 to 5 PhD students working there. Some of the ongoing project is we talked about the MBR before. Here you can see the result we got. We can lower with this MBR the phosphor limits from 10 to 6, nitrogen from 0.3 to 0.2, BUD7 from 8 to 5. And those figures we are quite sure about. Many times we are lower than that, but we cannot promise more to the government side. And we are also modifying SPR for advanced treatment. We are working with Anamox in the mainstream. Anamox is a technology to get rid of nitrogen in one step. You have 60% lower energy consumption. We have now very good result also with the mainstream, even at temperatures down to 15 degrees. We are working with anaerobic treatment in the mainstream. And modeling and simulation, we have also one PhD of failure of sensors. We want to know when sensor starts to give wrong information, because this is a problem everywhere, and if you don't recognize it earlier, the whole process can go in the wrong direction. We are using soft sensors to better measure different substances. We are measuring greenhouse gas, and especially N2O, which is a problem if you are not running it properly. We have been evaluating to take away microplastic. The good thing is that, as far as we know, like 98% of the microplastic will be in the sludge. The other side of the coin is that if you want to distribute that to farmland, I think very few farmers want to have so much microplastic. They want to have phosphorus and nitrogen. So you see here is a lot of other technology which I don't go into detail. So coming to the end of this, we have the idea, after being in touch with it a long time, that we should establish something similar together. We call it India-Sweden Water Innovation Center. So our idea is to establish something like this in India. And IVL is willing to be the Swedish partner. And we have support from the government and industry. We have access to experimental and analysis equipment. We have access to partners in Sweden and European Union. And we are used to work also abroad. And we have been in India for a couple of years. We are now engaged in several projects. But we also see the need, similar to Sweden, to have a third-party evaluation where you are not owner of the specific technology, but you can evaluate different technologies side by side so that industry and municipality can learn from this and which to use for them. So we think we've been in a bit discussion with Ministry of Water Resources about this before, and we hope we can move it on. We think our experience is that a pilot plant is necessary to be able to have a realistic scale to evaluate technologies. It's not enough in laboratory scale because it will be different when you do the upscaling. And we think it should be very good to have it also in India. And for sure, India should be the majority owner. We don't want to do this to earn money. We want to do it to be helpful, to find better solutions when you are investing so much as you are doing. And just a rough budget, what could be needed. We have an idea to have two different lines, one with different membranes and adsorption and precipitation, biological aeration. I don't need to go into all the details. We will discuss that with the actors. But totally, it's an investment like 5 million euro for the equipment. To that, we also need a building where to do this, and where it should be depends on the Indian side. we are now in Mumbai, but it can be in Delhi, or it can be wherever and you should have a partner, a research institute or university, or several of them. To sum it up and not taking too much of your time, so we think that the reuse of treated water from the sewage treatment plant is possible if you have a production facility. And we now have installation in Sweden where the energy, we produce energy, not use energy in the plant. And the nutrients can be reused sometimes with a sludge, but now we focus more on incineration of the sludge and recycling of the phosphor from the ashes. Industrial wastewater can be minimized by introducing kidney solution, as I showed you. And water solutions for an area need an integrated approach. We should think about the need for the farmers, industry, and the citizens, and all together to find the best optimization. And the climate change will do that. We will have less rain in many areas, but we will have more rain in other. So we'll have flooding and shortage at the same time. And we think that if we could establish such a common testing place like ISWIC, we could support a sustainable development by third-party evaluation. It should be similar like we have here, that we should have both government and industry involved. And the university could be strengthened by this. And yes, it could also deepen our cooperation, which we have started. And we could share experiences and develop new concepts. So I think we should not wait for the next opportunity. The one we have now is the opportunity. So we will be happy to discuss this now with you. And the picture actually is from my school studies where we would try to learn how many women we could see. So it took me a long time to see the elderly. Now I only see the elderly. I have a problem to see the young. Maybe it's all of the age. So thank you.
Thank you, Esther. Nice talk. Very nice talk. I would. There is tremendous opportunity between India and Sweden water technology, particularly in the urban wastewater treatment. India, if you have guessed by now, or if you know by now, that we are not a very water scarce country. We have a problem of water because the water management has not been very effective, and we are now taking steps to get the water management part and water governance part more organized. Wastewater treatment, use of treated wastewater is slowly emerging, whereas many states have now come out with policies on use recycle of the wastewater and to actually to reduce the demand of water from underground sources for industries. This is one thing which is slowly emerging. We have new policies are being laid out for use of treated water. As you mentioned, the presence of antibiotics and all these things are actually not very much discussed in the country because we are still in a slightly preliminary stage of getting the sewage treatment plants functional in parts of the country. India, the urbanization is taking place rapidly. Probably in another 20 years, we have about 50% of our population living in urban areas. And there will be a demand for these drinking water and in these urban areas. And the best part is that 80% of this water which people consume will come back as sewage. And so there is a tremendous scope for getting this water recycled and use these treated water for non-potable use. This is one thing which we have been now pushing it hard, is trying to popularize the concept of using treated water for non-potable purposes. This is a big challenge which we are facing. We, as you are aware, we also had the Namami Ganga, the National Mission for Clean Ganga, where we have been setting up a lot of STPs. Still, the sludge produced is a big concern for us, because we are not able to convince farmers or any other stakeholders take up and use this sludge for better use. We have been talking about using this sludge for fertilizer, for making, etc. But that part is not developed. So probably Sweden can and IVL can help us in getting the proper usage of sludge. Yes, we have got recent technologies coming up for reducing the volume of sludge by the water and dewatering the sludge and compressing it and then transporting. That plus is another issue where we were transporting the sludge was another issue. But now we have got this technology of reducing and dewatering the sludge and then trying to press it and take it away. So these are some of the issues which we have to address. And also you said about the footprint issue. Yeah, in many of the urban areas, the footprint is an issue because you don't have large land areas in the municipalities because of the high population density. May not have so much of large footprint area to set up this STP. So we require technologies which will require less footprint and also cost effective. One more thing, last point I would say, the membrane technology, we are not sure how much costly it would be, and second, whether we will be able to manufacture this membrane on our own, or whether we'll be locked on to some particular technology and to a country for the supply of membrane. Because the capital investment is done and then we are stuck with one particular vendor or a particular company for supplying this membrane, it will be very difficult for us. These are some of the concerns which we have. Membrane technology, yes, it reduces the footprint, but how often the casket has to be changed, how dependent would be on our country on those technology providers, that is one issue to be addressed. And how are also you addressing the issue of technology transfer? These are some of the things often it came to my mind. It is now open to anybody who can, if you can respond to this, what I have said, then we can open it up for the participants for any questions on that.
Yes, thank you. Yes, I finally know well your situation is not water shortage in that respect. Even if I, for example, follow Chennai and situation there. But I think what you mentioned in the end is about technology provider and dependence. That has been the driver for us to have this pilot testing plant, so we can invite different technology providers. We do the testing, we learn about the technology, but we also try always to have more than one technology provider that we can that can deliver equipment. And then we don't fully trust the information that we have from the references. So we do the testing in the individual cases, which I think is very important. For example, with the MBR, our testing has shown that we can lower the energy consumption and we can prolong the lifetime and we can minimize the chemical consumption with percentage like between 10 and 30%. And this is something that in our mind we could develop this together with Indian researcher. But also that you can develop your own solutions that could be of interest in such a demo plant, because new ideas will always come up. And I think also many Indian companies have good suggestions, so it could be good from an evaluation point of view, and those technology could also then be exported to other countries. So I see it also as a development project where we could share experiences and develop something together.
So shall we open for the official Q&A? Okay. So now we are officially opening the question answer session. For all those who had been our regular attendees are well versed with the format. However, all those who have joined us today for the very first time for the Water Tech Talk. So on your screen towards the right hand side, you have a chat box. You can definitely drop your queries by writing to us in the chat box. So you can also raise your hand. Once you raise your hand, your name will be called. You please introduce yourself and then kindly share your query and put forward your query. So now we are open for the Q&A. I can already see a couple of hands being raised. So here we go.
I request Mr. Raghav Nethi ji, you may please ask your query.
Hi, my name is Raghava Nethi. I'm from the World Bank. Thanks, Mr. Ken Green, for giving us very good overview of what's happening in Sweden. So I want to know whether there is any summary document as such that you have produced to understand as to how Sweden has come from where it was some time ago to now in terms of water usage, efficient use in different sectors, etc., and how it is benefiting economically overall. Thank you.
I can answer this. We in Smart City Sweden is writing this story, how it has been developed, and we also try to then describe, because in the 70s, when most of the wastewater treatment plant was established in Sweden, it was subsidized by the government heavily. So we tried to write the story and also introducing which policies has been the driver. In the industry, if you look at that, the driver has been regulation, but also industries, when we look back, they have learned that if they are in the front to be resource efficient, they have been more cost effective, to say. For the sewage treatment plant, it has been driven also by new regulation, so that everyone has to follow this. The problem we have also with sewage wastewater treatment plant is that they are asked to treat the water to specific quality, but they are not asked to take care of the sludge. So this is a problem I found everywhere. So in my mind, it should be different. You should ask them to treat the wastewater in such a way that you also find a way to recycle nutrients and produce energy. And this is not there. I could not find it in any place. So this is a problem from, in my mind, a regulation point of view. But to answer short, the story is there. I can send you more info about it, especially for the sewage. For the industry, it's a bit different for each industry type. But yes.
Now I request Mr. Ramashankar Jagwani. You may please ask your query.
Okay, good afternoon, Ashok. Good afternoon, Houston, and good afternoon, all the other panel members. I'm currently in Mumbai. I'm an environmental engineer with 30 years of experience in wastewater and desalination and water reuse. Although I've spent almost 20 plus years of my life working overseas, the question here is, and having worked in the wastewater industry, in sewage and in industrial wastewater, one of the biggest challenges we have, Houston, in our country is treatment of industrial wastewater by individual industries is considered as a negative investment. Okay. And I think that is where the mindset must change. There are few, what comes to my mind is, I think the industrial water has to be made expensive in a way that the cost of recycled and water which can be reused must become cheaper than fresh water that they withdraw. That'll be the first incentive. And I think second incentive could be that we could give them credit, whether it's carbon credit or it is environment credit or whatever way we could roll out a credit policy where the lesser the fresh water they use, the more credibility they get for their industry and their operation. When it comes to now talking about recycle and reuse of sewage to drinking water, yes, Singapore is the perfect example. They started using any water, which is recycled sewage. Our country has an issue of acceptability of this concept first and foremost. Culturally, from religious mindset, there are many issues. So unless we change the mindset of our, I know the youth don't care too much about it as long as they get drinking water, good quality. I think from that perspective, the young generation has a different mindset. The older generation and people staying in rural areas, there is a mind block on these things. That needs to be addressed. And I agree with Mr. Ashok Kumar on his view about MBR. I have not seen very large sewage treatment plants based on MBR. We are talking about 100 MLD, 150, 200, 300 MLD sewage treatment plants. India is a big country. Decentralized, small, that's a different story. But the moment you go to large sewage treatment plants, I believe instead of doing MBR, the better option is to do either a SBR or an activated sludge followed by polishing with an ultrafiltration plant. That gives the flexibility. That gives lots of options depending on horses for courses where we want to use the water. So these are a few points that I took from when I saw your presentation and I had in my mind. That's all that I need to say. Thank you.
Thank you very much for those ideas. To start from the end, so we don't promote MBR before activated sludge and SBR. Why this will be installed in Stockholm is mainly a question about area. They will double the capacity, but they don't have the land. That's why MBR is introduced. And by doing this, they also get a better treatment result. But this can be reached also with SBR and activated sludge. So you're totally right there. You need that mixture. But in many cities where you have this problem with land, MBR will be a good possibility. That's about MBR. What is especially good with MBR, we found, is that the polishing will be a bit more simple because you don't have any particles at all. But this can be also solved with other technology. If you remember when I talked about this installation in Sweden, we were using another filter to get rid of the particles. So it can be done with SBR and activated sludge, that's for sure. Mindset, you're right. We have the same problem with mindset. That was the reason why we produced that beer. It has been on YouTube for now a long time, and it's one of the most of interest, this movie. But it takes time to change mindset, even if water goes around. What we try to tackle is to measure online the quality, because if you recycle and are not sure about the quality, you can run into problem. That's why we prefer that you take it back to the groundwater through infiltration, so you have a treatment step more. I saw in US when they recycled in San Diego directly, and then you must be very, very sure that the quality is always good. And then about the industry, it's correct that you look at it as a negative cost. The driver has been in Sweden, two different drivers. First, you are not allowed to enlarge your industrial capacity if you don't show that you are using best available technology. So that has been necessary then to rethink how you do the production. Another driver is to introduce solutions in the production line that also saves money. I give you one example. When you are using pickling of stainless steel, you are using very strong acids, HF, HNO3. We introduced in China a recycling technology where the payback is 3 months. 3 months is so low, so every industry will do this, and with the economy as a driver. So you can also find that you can introduce technology inside factories that is positive for the economy. So I think that is also something that could be a combination of strong legislation. And for us, it has been very important when we run project in Hyderabad with CII, and for some clean technology, we have the same view. But I mean, this is everywhere a problem, that you must have strong regulation, but you also must have to find economic initiative.
Adding on to that, the first point about the mindset, where we really have to recycle this sewage water for drinking purposes. We have not, fortunately, probably we have not reached a stage. There's so much of shortage of water. As I said, probably if we can manage the water properly, we may get sufficient water. See, one best example is agriculture, which uses about 80 to 85% of water irrigation. The water use efficiency is only just 30-35%. If we can improve the irrigation techniques in the state and probably do something about the better cropping patterns, where crops which do not guzzle water, like sugarcane and paddy, is not taken up in areas where there's a water stress, or where we can use better irrigation techniques like micro irrigation and the sprinkler system, and avoid water wasting techniques like flood irrigation, etc., for paddy, or even Siri and the new technology developed for paddy cultivation. We probably can save a lot of water. So then, if we can save that much of water, probably we can give it for the drinking water and in industry purpose. So I don't think we really have to worry about putting this water, sewage water treated and bringing it for the drinking water purpose as of now. But one important point is to change the mindset to respect water and to have a value of water. It may not be pricing of water, but a value for water. That's one thing. Second is, there is tremendous scope for recycling the grey water, because sewage water requires all sort of process, but the sewage water grey water can really look at grey water can be recycled without much probably mental block, and that can be done. And see, the first step, I think, should be to use the recycled water or treated wastewater for non-potable purposes. There are a lot of non-potable purposes like irrigation, as again said. It takes up a lot of fresh water from the underground and uses for irrigation. So if we can substitute these water being used in the irrigation, either from the rivers or from the underground, by this treated water, probably we can save a lot of fresh water being taken up for these purposes. That's one thing. And the policies of the government like Gujarat and all, which have come out with treated water usage as a must for industries, is a very welcome sign. If you notice, in Gujarat, we cannot have an industry set up by using the groundwater or water taken from river, unless you take a permission of non-availability from the municipality. The municipalities around that has to, first priority will be to take this treated water from the municipalities. This has really helped in many ways. One, the sewage treated water demand has gone up because the industry is forced to take it from the municipalities. Second, it has improved the financial conditions of the municipalities. There are municipalities, the Surat Municipal Commissioner was telling, they have about 140 crores every year from the sale of treated water. In fact, which covers the cost of giving drinking water supply. So this is one thing which probably we'll have to examine: the substitution of treated water for non-potable purposes, and substitution of clean water, which is presently being used. That's probably the first step to change the mindset. Thank you.
Now I request Mr. Amba Shetty, you may please ask your query.
Just a second, Neha. Sir, yeah. I also would like to add here, being the communicator of the sector, you see, like you rightly mentioned, that there are other uses also of the recycled water which can be taken up, especially when we talk about India, because, you know, here we still have that challenge of infrastructure as far as the distributor channel are concerned. So definitely, but sir, having said that, I feel behavioral change is something which is an ongoing process, and there the younger generation can certainly contribute in a bigger way. Like even if you talk about the this campaign, the drive which you have started, the Catch the Rain one. So you know, when it is coming from the youth side, definitely it will have a better pull. So I personally feel that for the behavioral change also, it should go on. As far as, you know, we keep developing our policies, one way we are keep developing our infrastructure, but this should be an ongoing process, and I think our ministry and other concerned departments are already taking this initiative, and we all have to come together and make it a Jan Andolan, which we all have been doing. So just wanted to share this as well, sir. Thank you.
Good afternoon. I am Professor Amba Shetty from NITK Surathkal. Can you hear me? Can you hear me?
Yes, ma'am.
Yeah, I have two questions. First question is to Austin. I want to ask, to what extent this wastewater, I mean the domestic wastewater and the industrial wastewater, is being put to use in Sweden, and what is the kind of use there? Hello?
Yes, first about the sewage wastewater. So we treat roughly 98% of all that water. Most of that will be treated and let out. So why it starts to be changed now is because we have water shortage in the southeast and on the island. And there we have started to reuse the water through the groundwater and then being used by the municipalities. We also treat on an island, we take industrial wastewater from a slaughtery and we treat that with reverse osmosis, and then it is used as fresh water in that village. So it's not very much introduced, dependent on that we have very good capacity for water. We take most of the water from the surface water here in Sweden. For the industry, it's very different. The industry has minimized the use of water step by step for many years, and we now have a couple of industries that don't let out any water at all. And it is of their own interest because they can be more efficient in this way. We also use the energy in the outlet water from both municipalities and industry. So we have heat pumps to collect it, and we use it for district heating and district cooling, I would say all over the country. But the reuse of water is very limited because it's a new thing coming up here in Sweden with this water shortage.
Now I request Ms. Nupur Bahadur. You may please ask your query.
Hello, good afternoon. Am I audible?
Yes, yes.
Yes. So myself, Dr. Nupur Bahadur, a senior scientist from TERI, New Delhi. So my question to the speaker, first of all, the presentation was very good. It was good to learn about the activities and the case studies taken up in Sweden. So my pertinent question is that, which was asked by the earlier speaker as well, that first question is that are you able to treat the water to a quality for high-end applications? And secondly, in Sweden, is the possibility, has it been explored to integrate advanced oxidation processes with MBR to enhance treated water quality for better reuse?
There were two questions. Yes, we have studied MBR with advanced oxidation. So now in Sweden, also ozone has been introduced in 3 cities to get rid of pharmaceutical residues. What was your first question? Forgot it. Can you repeat your first question?
Yeah, my first question is that is the current treatment which you are undertaking, so water quality. So the question is that is the water quality sufficient enough for high-end reuse like cooling towers or other high-end applications?
I would say the quality is very good. When we produced the beer, as I said, the water quality was too good because you need the salt to get the good beer. So it depends on, we are evaluating different treatment because of what is the need of the water. So it's a question about technology and cost, I would say. But with the step we have introduced, water can be reused. Also, you mentioned for cooling purpose. Yes, we are also dealing with the cooling water, how to treat that water in a smarter way, not using so much chemicals, but using, as you mentioned, oxidation technology to minimize the growth of bacteria. So this is also introduced in large scale. But I see also the water that you should in an area see what is most needed, as also introduced by Mr. Komar. Farmers are using most of the water in many countries. So we must build up a system so that we can recycle water for the purpose they have. And then the quality should be, in principle, they need to have phosphor and nitrogen there because it's a nutrient. So the tricky thing is then how to treat sewage wastewater in such a way that it only includes those parameters. But I think it is, I mean, if you look worldwide, the recycling is for farmer is the number one. So I think the quality issue you raise, you can reach the quality with the technology I mentioned. Then it's a question about how much you're willing to pay for to reach that quality. So it must be compared with other solutions.
So there is another query which has come in the chat box. So Mr. Krishna Kumar from Kerala, he is requesting you to share your experiences of complex problems of below sea level communities engaged in agri, fishing and tourism, as the problems they are facing are saltwater intrusion, pesticide contamination, annual flood damage, daily tidal surge, etc. So over to you, Austin.
This was the toughest question today. I cannot give answer to that. The only thing we have similar is the salt coming into our on the island outside Stockholm. We have salt in the wells. So then you must start to treat it. So many of them have introduced small-scale reverse osmosis units. The other questions, I'm not familiar with it. I'm sorry, I cannot give an answer to that.
Shubha, in one of our talk, we have the people from Netherlands coming us. So they have this problem of land under the sea level, so dikes and all these things. So we had a presentation last week. They also come in the one of the future water talks about how the seawater intrusion into the lands were protected and the technology used for Room for River project. There's a project in Netherlands called Room for River that will come up in one of our next future water tech talk. Please bear with us. Thank you.
Now I request Ms. Poonam Mathur. You may please ask your query.
Can you hear me?
Yes, ma'am.
Yes, I'm calling from Houston, Texas, and I have been involved in water and desalination consultancy for a while. And I think including the institute like IIT Kanpur, where I am from, I'm a chemical engineer from IIT Kanpur. And I think using the students from there would be a very good idea. If we start, especially if we build a pilot project in Kanpur, we can have a win-win situation, take the discharges from Ganga and use it for anaerobic digestion and have the power from there and put it in the, because Kanpur is very power deficient. Put it in the power line. We can clean up Ganga and we can also have power. And we can, like Austin said, we can use the dewatered sludge to incinerate it and use the phosphorus from there for the farmers. So if we start a small pilot plant in Kanpur and involve IIT Kanpur second and third year students as an intern, they would be trained well to take over once they graduate. And I've been trying to get involved with Water Institute of India. So Ashok Kumar, you are the perfect person to get involved with in this situation. But perhaps you can guide us how to go about doing a small pilot project in Kanpur and how to involve the students, because this is a win-win situation. You take the human and animal waste from Ganga, so you have cleaned up the river and you have used that for anaerobic digestion, so you have the power. And Ganga, when it comes to Kanpur, does become very dirty because all the industries are throwing their untreated sludge in the river. So I'm quite familiar because my ancestral home is only 100 meters away from Ganges River. So it's not really a question, it's just my thought. Any solutions you can offer, I would be very willing to listen.
When you visited Kanpur last, did you go there recently?
5 years ago.
Yes, a lot of things have changed. In Kanpur. I just to tell you, you remember the Sismavo Nala, which used to spawn about 1.4 million liters of sewage water every day to Ganges River. Not a drop comes out now. So that Sismavo Nala, which is about 20 feet wide, almost 10 to 15 feet wide, a canal which used to put in about 1.5 billion liters of water, sewage water and dirty water to Ganga is now closed. Not a drop of water comes down. And we have actually from the Namami Ganga, the National Mission for Clean Ganga, establishing more than 430 MLD sewage treatment plants are all there, and the output of sewage there is only about less than 400. So we have a capacity being in the process of being built for more than the requirement or projected requirement up to 2025. Different plants are coming up. Second, the biggest problem in Kanpur had been the industrial waste coming from tanneries and all. So with the STP with about 700 crore is being built there. The EFT, effluent treatment plant, is being built there, and that with the support of industries, the industries and the district administration, they all joined together to form a body which will ensure that the only treated water effluent from these tanneries come to the river. And the stink of today morning, why I'm telling this, because today morning also we had a webinar on treated water, particularly concentrating on the Kanpur side. And one of the speaker was telling that he was studied in IIT Kanpur, said that when we studied in Kanpur IIT, we could smell Kanpur 10 kilometers away. We knew that the Kanpur station is coming, but now it is very clean. The air is also very clean, and the water in Ganga is also very clean. And incidentally, last meeting of the National Council for Ganga, the body headed by the Prime Minister himself, with about 10 union ministers and 5 chief ministers and other very, very senior people of the country as members. The first meeting of the National Ganga Council was held in Kanpur because PM insisted that the meeting be held in Kanpur because of these issues associated with that, and we had to really work out. I was also part of the Namami Ganga program. The Namami Ganga program has been doing an excellent job and phenomenally good work in getting these Ganga cleaned up. So I agree with your suggestion that there could be better participation if possible. IIT Kanpur is there. They're also helping us in finding solutions. Professor Vinod Tare is there, and there's a Ganga unit established, Center for Ganga unit established there, which actually evaluates various technologies, STP technology and other technologies related to cleaning of water, which will be utilized in the Namami Ganga project. So, further thing we can, please email me. We'll touch base with you and link up with the authorities concerned. We have from the National Water Mission as well as the National Mission for Clean Ganga, very closely associated with IIT Kanpur and the research projects which is going there. And in fact, the next water technology talk also will be a person from the IIT Kanpur on the water quality, because we need a very, very useful implements and technology which can measure the quality of water, because this is one point which was mentioned that we should have very handy portable devices so that the local people can test the quality of water and then make the complaint. As of now, water testing, quality testing is a major concern because the labs are far and few. It's all separated, kept very far away. So the what IIT Kanpur has been working on getting very, very low-cost solution, portable equipments which can measure the quality of water, which incidentally would be the most probably the next speaker in our water talk, water tech talk next month. So you can also join in that. And your suggestion for making a partnership with IIT Madras and you and IIT Kanpur and Namma Ganga will work on that. Thank you.
So there is a query, the other perspective being shared by one of the PhD research scholar, Smita Singh, who writes that, do you think that farmer will prefer using wastewater because it's going to decrease the crop yield capacity, as there are a lot of legume crops which are quite sensitive. So that's what she's saying. And I think if I'm reading it right, Smita, if you have anything else to add on, you may please raise your hand and we can unmute you and you can directly put forward your query to the expert panel. Otherwise, this is what she has written. And over to you, Ashok sir. I think, what do you have to say on this, sir?
No, I am not very sure about what you said. I don't know whether it's legume crops, the productivity goes down. But I have whatever seminars and information I attended, and the information I have is that there are areas where the farmers are demanding the treated water because it has lot of organic content in that, and it really enhances the productivity. Actually, if you look at the city of Bangalore, the treated water is being taken away by the farmers at a cost to their field because their productivity has increased. And Bangalore city is one good example where there's a lot of demand for the treated water coming from the STPs. In northern parts of the country, there is some mindset problem, as you rightly said, of taking this water. But I think with probably more awareness generation, they should not have any problem. And simply, we can substitute this water, this sewage, the treated water, good quality, and save the clean water which is being taken away from the ground as well as from rivers. That will be good initiative, because we find many places Ganga itself does not have water in the Ganga river in some places because all water has been diverted to Ganga channel and use it for irrigation. If we can do substitution for that water, it will be good to see that rivers flowing. Because one of the concept of river, one of the main themes of Namami Ganga program is also Aviral Ganga. That is, Nirmal Dhara is the purification of water, but Aviral Ganga is to ensure that continuous flow of water, which is some places now missing. Probably if we do the substitution of water for irrigation by this treated water, probably we can have continuous water flow in the rivers, and that makes the river more river-like and more healthy.
Now I request Ms. Samanpreet Kaur, you may please ask your query.
Yeah, thank you. Thank you so much. So good evening, everyone. So first of all, I would like to thank the speaker for such a wonderful presentation and talk on the water treatment. My particular question is to Dr. Ashok Kumar, and I am from Punjab Agriculture University, Ludhiana, and here we have one of the, Dr. Ashok Kumar rightly said, that there are drainage systems or there are surface water bodies which are being contaminated by the industrial waste. So in our place we have many textile industries and the hosiery industries and the cycle industries which are polluting our surface water supplies. And is there any possibility, like the speaker has presented, is there a possibility of a bigger project that is funded by the NHM, and the pilot works can be done through our university systems, and we can come up with some good technologies that can be used for the treatment?
Yes, I think I'll take 2 points on this. One, in Ludhiana, there have been a lot of correspondence we have been taking up taking up the treatment plants there. Our ministry is also seized with the matter, and I think the correspondence are going on for establishment of treatment plant there, because a lot of industrial effluents are polluting the 2 major. I forgot the names of the. It's our team also had visited that. I don't know so that. Second important thing in Punjab, as you're aware, the overexploitation of groundwater has been a major problem of concern. That's where we started the Sahi Fasal campaign, where we wanted it may not be politically correct to speak it out now at this present situation, but in 2019, November 14, we had the workshop in Amritsar, when we actually were telling the farmers, 1,000 people were there in the workshop in Amritsar, where we told them that about the depletion of groundwater which is happening because of the excess cultivation of paddy. So this is something which probably we have to think, cool mind, whether we really require so much of paddy in Punjab and go for a crop diversification. One of the effect of our campaign Sahi Fasal in Punjab and Haryana was that in Haryana they had banned paddy cultivation about 1 lakh acres of India in part of some of the highly water stressed blocks. Also gave incentive for about 7,000 rupees per acre for maize in cultivation. Probably this is one thing which we have to address. Punjab University has to take a lead in really educating people of the overexploitation of groundwater in Punjab. 70%, 75% of irrigation in Punjab presently happens with groundwater. We all tend to assume that the Punjab with a lot of the rivers and Patranangal dams and all, majority of irrigation would be surface water. But unfortunately, 70 to 75% of irrigation in Punjab is presently groundwater, and the free power given to the farmers. The exploitation of groundwater has been very excessive, and the water table has gone down in many areas. This Jalandhar, the Ludhiana issue, we can talk separately. I think there are some discussions being done to prevent the water polluting, the industries polluting, which we are doing. I think a big project report was also submitted, I believe. That's all I can put on a public platform now.
So apologies, but we can't take any more queries due to paucity of time. We have to give a pause here as far as the Q&A is concerned. There are still a lot of questions which are there. So in case you are not getting your reply at this moment, please write to us, and we'll try and share the FAQ also, which will be uploaded on National Water Mission's website. So with this, we pause from the Q&A session. Over to you, Ashok, sir.
Thanks a lot. I think, thanks for all the participants for coming in it. The formal vote of thanks will be given by Mr. Sushil Arora, advisor in National Water Mission. I have only one point to make. Kindly join us in the water talk, which will come in the next month. Third Friday, we have a water talk, which will be delivered by one of the eminent activists in the field of water. And also, kindly join us in our campaign Catch the Rain. This is one program which we want to make it a success by involving all people. The campaign is part of the awareness generation part of the campaign is started on December 21st. Navriva Kendra is going all over the place in all districts of the country to make people aware of the necessity to catch the rain. And if we can keep our vessels ready, as I said before, if we can get our encroachments from the ponds removed, if we can deepen our ponds, we can create rainwater harvesting structures in all our buildings, rainwater harvesting structures, we probably will be able to catch a substantial amount of rain, which will help us in increasing the water table. And as I said, would like to make Tangar Mukt. Thank you. Over to Sunil.
Am I audible?
Yes, sir.
Thank you. A very good afternoon to all of you. On behalf of National Water Mission, I extend a hearty thanks to all of you for sparing your valuable time for attending this fourth Water Tech Talk. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion to such an intellectual delegates. Let me first of all start by giving glory to Almighty God for making today's occasion a resounding success. We are really grateful to our Additional Secretary and Mission Director, sir, for his able guidance, which has always encouraged us for organizing Water Tech Talk series. He is the driving force behind this talk series. The inception of the Water Tech Talk, as you all know, that has been initiated from 9th of October 2020. And this is the fourth Water Tech Talk in that series. I hope you all must have enjoyed this session of Water Tech Talk, as well as experiences shared by speaker. Senior advisor responsible for special guests, he had explained in a very simple manner that tackling water-related problems requires collective efforts. He has shown us how we came from mechanical treatment in 1930 to membrane technology in 2020. His idea is water solution of an area need an integrated approach. We came to know today that wastewater is a new gold. It is surprise news for us that Sweden first beer was brewed from wastewater only. He has also explained that in the wastewater management, there is a need of synergies between water and sewers and waste and energy. I also express my heartfelt thanks to all of the delegate attendees for joining this session of Water Tech Talk on a virtual platform and had a patient hearing to our speaker to make this event wonderful and successful. I also convey my sincere thanks to Team Water Digest and Team National Water Mission for giving their wholeheartedly support in organizing this Water Tech Talk, who actually worked behind the screen. Thanks to all of you again, including attendees, for making this Water Tech Talk a resounding success. At last, I want to say, when not in use, don't let the water flow. We all must conserve the H2O. Mata hai bhumi, pita hai pani, yahi keh rahi hai gurbani. See you all in next episode of Water Tech Talk next month. Till then, goodbye, take care and stay safe. Thank you very much. Jai Hind.
Thank you, everybody.
So thank you, everyone. And like Ashokji mentioned, that we are coming up with the water talk next Friday.